In this session of geometric progression, we will study about the assumptions. If there are total number of terms n is odd, then what we have to take the assumptions. There are two conditions: the total number of terms is even or odd. So first we see about the odd. If n is odd, so n may be equal to 3, 5, 7 and so on. For this we have to take the assumptions a upon r, a and ar. Here you see t1 is a upon r, t2 is a and t3 is a into r. If n is equal to, we see the common ratio of this. What would be the common ratio? We see the common ratio. Which is equal to t2 upon t1. It is a upon a by r. So is equal to r. The common ratio for this is r. So if we have the total numbers of terms are 5, then what will happen? We see here, if n is equal to 5, then what will this? The n is equal to 3. Here the n is equal to 3. Here we see the n is equal to 5. What will happen? We have to divide t1 by common ratio and multiply t3 with common ratio. We will get the fifth term. Here we will get the first term. So t1 divided by r, a upon r, a, ar and t3 multiplied by r. So we see what happened. t1 is a upon r and again divided by r, dividing by r. Here a upon r, a, ar, ar into r. So it would be a upon r square, a upon r square, a upon r, a, ar, ar square. So if n is equal to 5, we have to take the assumptions. First term should be a upon r square, second term a upon r, third term a, ar, ar square. So we can write in this way. This is the t1, t2, t3, t4 and t5. The same way we could find out the, if n is equal to 7, again we have to divide t1 by r and t5 by multiply t5 by r. So we could get the total 7 terms. Now we see here another thing. If n is even, the total number of terms are even, then n should be 2, 4, 6, 8 and so on. If n is equal to 2, then what will happen? We see the assumptions we have to take: a by r and AR. these assumptions we have to take. Here the first term T1 and the second term T2. Now we find out the common ratio. T2 upon T1. You see here what happened. T2 is AR and T1 is A upon R. So we will get R square. The common ratio would be here R square. Common ratio is R square. So what we have to do, if n is equal to 4, if n is equal to 4, what we have to do, we have to divide T1 by common ratio. So what we will get here, the first term would be T1, what we have taken here in the n is equal to 2, divide by R square, then A upon R, the T1 is there, AR, and multiply T2 with R square. So we will get T1, we already got A upon R and divided by R square. This is A upon R, this is AR, or this is AR into R square. So in this way we will get the term A upon R cube, A upon R, AR and AR cube. So this would be the first term T1, T2, T3 and T4. So this is the assumptions we have to take if the total number of terms are even. So we have seen what assumptions we have to take if the number of terms are even or odd. Let us take one example for both sort of problems. I am putting one question here. Let us take a question. The sum of first three terms of GP is 39 by 10 and their product is 1. Find the common ratio and terms. So first of all we have to see that in solution given n is odd, the total number of first three terms, n is odd. So n is odd, then what we have to assume, the given they have given the sum of all three terms is 39 by 10 and product 1. What we have to find out? Common ratio. To find common ratio, R we have to find out, and the terms. Terms we have to find out. Now let us start this solution. Because the total number of terms are odd, then what assumptions we have to take, I have told you earlier. So we see, let the terms are A upon R, A and AR. So as per first condition, because we know that sum of terms is equal to 39 upon 10. So therefore A upon R plus A into R is equal to 39 upon 10. This is the first equation we have got. Again, because product of all terms is equal to 1. Therefore, A upon R into A into AR is equal to 1. Implies to, here you see R and R will eliminate and A cube is equal to 1. Therefore, A is equal to 1. This value of A we will put in equation number 1. Putting A is equal to 1 in equation first. So we will get 1 by R plus 1 plus R is equal to 39 by 10. Implies to 1 plus R square upon R is equal to 39 by 10. Implies to 10 plus 10R plus 10R square is equal to 39R. So therefore we will get 10R square minus 29R plus 10 is equal to 0. We have got the quadratic equation. Now this quadratic equation we will split the middle term, we will get the answer. So we will get implies to 10R square 25R minus 4R plus 10 is equal to 0. Implies to 2R we will take outside from this. Here you see, here and here. So 5R we are taking outside. So 2R minus 5 minus 2 we are taking outside from here. So 2R minus 5 is equal to 0. So 2R minus 5 and 5R minus 2 is equal to 0. So we will get 2R minus 5 is equal to 0 or 5R minus 2 is equal to 0. Therefore, R is equal to 5 by 2 or R is equal to 2 by 5. Now we have got the common ratio. R either may be 5 by 2 or maybe 2 by 5. If we take 5 by 2, If we take 5 by 2, if r is equal to 5 by 2, so the terms would be, because T1 is equal to A upon R, A is 1 we have got, and R is 5 by 2, so it is 2 by 5. Similarly, T2 is equal to A, which is 1. T3 is equal to A into R, A is 1, R is 5 by 2, so it is 5 by 2. So the reply, if R is equal to 5 by 2, then the terms would be 2 by 5, 1 and 5 by 2. If R is equal to 2 by 5, then what will happen, we see. If R is equal to 2 by 5, then T1, which is equal to A upon R, is equal to A is 1 and R is 2 by 5, so it is 5 by 2. T2, which is A, is equal to 1 again, and T3, which is 1 into, or which is A into R, A is 1 and R is 2 by 5, which is 2 by 5. So in this manner we will get the geometric progression 5 by 2, 1 and 2 by 5. So in this way we could easily find out the terms. If the some other conditions are given, the product of the terms and the sum of the terms and the number of terms is given, and we have to find out the terms and the common ratio, we can easily find out through this technique. Let us take another example. 4 terms are in GP. Sum of first 2 terms is 8 and the sum of last 2 terms is 72. Find the terms. Here the total number of terms are even, because there are 4 terms. So what we have to take the assumptions? We start with the solution directly. Let the terms are A upon R cube, A upon R, A into R and AR cube. So as per first condition, sum of first 2 terms is 8. It means T1 plus T2 T1 plus T2 is equal to 8. So T1 is A upon R cube and T2 is A upon R is equal to 8. I am getting outside from it. I am getting outside A. One upon R cube plus 1 upon r is equal to 8. This is the equation number 1. I again little bit I solve through this. So we will get here r square 1 plus r square upon r cube. So I will take the LCM of this r cube, and it is 1 plus r square is equal to 8. This is equation number 1 we have got. As per second condition, last two terms, sum of last two terms is 72. So T3 plus T4 is equal to 72. T3 is AR and T4 is AR cube is equal to 72. So we can write in this way: AR 1 plus R square is equal to 72. This is the equation number 2. Now what we have to do? We have to divide equation number 1 by equation number 2. Now dividing equation number 1 by equation number 2. So A 1 plus r square upon r cube divided by AR 1 plus r square is equal to 8 by 72. See here, A and A will eliminate, and this 1 plus r square will eliminate. So we will get here 1 upon r power 4 is equal to 8 by 72. So here 8 by 72 we can again divide this also. 8 1 is 8, 8 9 is 72. So we will get here 1 by 9. Now r power 4 is equal to 9. I just put the symbols here. Therefore implies, and we have to take the fourth root, implies r power 4 is equal to plus minus root 3 power 4. So we will get the powers are same, they will eliminate to each other, and therefore r is equal to plus minus root 3. We have got the r now. Now just we have to put the r in equation. First I put plus root 3 and I would try to find out the other terms. For this we have only got r here, we have to find out the e. So from equation 2, putting the value of r, in equation 2. So equation 2 is, we have, because a r 1 plus r square is equal to 72 is equation number 2. We are putting here r is equal to root 3. So I will get a into root 3 1 plus root 3 square is equal to 72, implies to a into root 3 1 plus 3 is equal to 72, implies to a root 3 sorry a, here we get 4, 3 plus 1 4, a root 3 is equal to 72, implies a is equal to 72 upon 4 root 3, implies a is equal to 4 1 4, 4 1 4, 4 8 32. So it is the 18 by root 3, implies to a is equal to 18, we can write in this way 6 root 3, because here I will explain you how we will got 6 root 3, because 6 into 3 is 18 by root 3. Here what we are doing, 6 into root 3 into root 3 by root 3, and this will eliminate, and 6 root 3 we will get. So we have got a and r both. So now we can easily put the value of these in the assumptions what we have assumed. So I will do it here. You see, we know that T1 is a upon r cube. So a is 6 root 3. We will put a 6 root 3, and r we are taking root 3. So root 3 power 3. So it is 6 by 3, which is equal to 2. T2 is a upon r. A is 6 root 3 and r is root 3, which is equal to 6. T3 a into r. A is 6 root 3, r is root 3, 6 3s are 18, and T4 a r cube, it is 6 root 3 into root 3 cube, which is 54. So we have got the answer. The GP would be 2, 6, 18 and 54. This would be the answer of this problem, or in this way we could easily find out the problems relating to the even number of terms given in geometric progression.